These two examples are looking at transformations due to reflections. So very easy to do, just the same method as used for reflections right back at key stage 3. Count the number of units from the x-axis or y-axis, depending on what ones are mirror line, and reflect that on the other side. So if we look in part 1, it wants us to draw the function f of minus x. So this one is a reflection in the y-axis. So if it's the whole function being multiplied through by, if it's the x term being multiplied through by minus 1, then we reflect in the y-axis. So if it's within the bracket, it's y-axis. If it's in front of the function, it's an x-axis in this case. So all we're going to do is reflect the curve. So if we just pick a few points, so for example, this point at 0, minus 1, we'll move across to 0, 1. It is 1 unit away from the mirror line, the y-axis, so we need to reflect it 1 unit on the other side. Pick another few points of the curve and do the same, and then sketch in the general shape. So in part 2, we have a reflection in the x-axis, and we know that it's a reflection in the x-axis, because we've been asked to draw minus f of x, so the whole function is being multiplied through by a minus 1. So we're going to use the x-axis here as our mirror line. All we need to do, same as before, pick a few points and reflect them in the mirror line and draw in the shape. So if we look at the point minus 2, 2, it's going to be reflected down to minus 2, minus 2. The point at minus 1, 0 will stay the same as it's on the mirror line, so any points in the mirror line do not move. Same for this point. Another point we could look at is this one here. 2, 2 will be reflected down to 2, minus 2. So once we've plotted a few points, then we can just draw in the general shape of our curve. This next example is slightly different. So we've been given the original function f of x, which is this curve here, x cubed plus 1, and it's shown with two related graphs, g of x and h of x, just two transformed functions. What we have to do is describe the transformation and then write down the equations. So let's start with how we get from f of x to g of x. So if we take a look at our curve f of x, so maybe if I just go over it in red as best I can, so we can see what one f of x is. And we want to find out how we get from it to g of x. So is it a translation or is it a stretch? Just from looking at it, to me it looks like it's just been shifted down. So I'm going to pick a couple of points and see what's happened. So if I pick this coordinate here at 0, 1, it's been moved down to 0, minus 1. It's gone down 2 units. So let's see if that's true for other points. So at 1, 2, this has moved down to 1, 0. So again, it's been shifted down by 2 units. So to get from f of x to g of x, all it is a translation of 2 units down. So a translation of 2 units parallel to the y-axis. Now, what we need to do is write the equation of g of x. So what we do is take our equation for f of x, which is the x cubed plus 1, and we want to take 2 away from it. So it's like our original f of x minus a. So you take away the amount you're translating down by. And if we do that, 1 take away 2, we get x cubed minus 1 as our equation for g of x. If we now compare f of x to h of x to see how we transform the function f of x to get h of x. So just from looking at f of x and h of x, so let's draw h of x in blue. There hasn't seemed to be any translation. It hasn't moved up or down or left or right. Doesn't look like a reflection, so our other only option is a stretch. So we've just got to figure out if it's a stretch parallel to the x-axis or the y-axis. If we examine this point here that's at 0, 1, it remains the same in the f of x function and the h of x. So that y coordinate of 1 has remained unchanged. Remember, when we're doing x-axis stretches, it's only the x coordinates change. The y coordinates do not change, so it's indicating that it's an x-axis stretch. So if we look at a couple of other points maybe to see what was happening. So this coordinate here, 1, 2, has moved, stayed at 2, but the x coordinates changed to a half. So it's moved from 1 to a half. So what that means is it's a stretch parallel to the x-axis. The scale factor is a half because everything has, all the x coordinates have been divided by 2 or multiplied by a half to get to the h of x. Remember, for the equation, if the scale factor is a half, the value of a in your equation, so what we've got is y equals f of ax for x-axis stretches. If the scale factor is a half, the value of a is its reciprocal, so it's 2. So what we're going to do is try and write our new equation. To get the equation for h of x, then all we need to do is multiply by 2. So we need 2x all cubed plus 1. So we end up with 8. If we cube 2, we get 8x cubed plus 1 to be our equation.